Today, we're talking with Ted Feldman, the CEO and founder of Durin Mining.
Mining as a whole does not like to invest in R&D. We're not particularly good at R&D. And that is because commodities are cyclical.
Durin is helping to unlock these supply chain bottlenecks by building automated drilling rigs that can dramatically cut the time and cost of finding these new mineral deposits.
I went to Rio Tinto's remote operations center. Rio Tinto is the second largest miner in the world. Everyone is so excited to help startups, and our conversation was pretty much all about mining.
He has had a remarkable year, already putting his rigs in the field, building out a team, and proving that what they can do is much more efficient and saves a lot of money.
I think the drilling company that's actually getting the geological data is the one best suited to build that software. So yeah, the metallurgical test work, that's what I'm really interested to see.
Hey everyone, welcome back to the Clean Techies podcast. I'm Silas Maynor, Clean Tech Headhunter, and today I will be your host. So as usual, we're always here to talk with the builders of our clean future. And today we're digging into a topic that's typically overlooked, and that's critical minerals. And what products, when you think about the climate transition, are really kind of front and center. We've got electric vehicles, solar panels, all of the transmission lines that we have to build. And all of these things require a massive amount of metals and minerals to build. You know, just think about the number of batteries that we're building in general right now. Those are all critical minerals, and we need them from somewhere. But the problem is we don't have enough of them. And the supply chains that we do get them from often come from places where the production methods are just super destructive and just really, really bad for the environment. Places like China or Indonesia, where there's not a lot of regulation into how these things are done. So all of this makes our climate problems even worse. So we're trying to make a cleaner future, but in the meantime, we're getting these things from places that are just absolutely destroying the environment. It doesn't really make a lot of sense. The solution is to find a better, cleaner, and faster way to get these minerals out of the ground. And that's why today we're talking with Ted Feldman, the CEO and founder of Durin Mining. Durin is helping to unlock these supply chain bottlenecks by building automated drilling rigs that can dramatically cut the time and cost of finding these new mineral deposits. And they estimate that in the next couple of years, they can reduce the cost of exploration by somewhere between 50 to 75%, which is a really, really large cut. And Ted, he has had a remarkable year, already putting his rigs in the field, building out a team, and proving that what they can do is much more efficient and saves a lot of money in terms of how we find these minerals so that we can power the clean energy transition. So if you're interested in how we can solve one of the biggest challenges facing clean tech today, this episode is for you. Before we get started, shout out to EarthSearch for sponsoring this episode. If you need to hire for your clean tech startup, reach out today to get the best support in the market at prices that even a seed stage startup can afford. All right, enjoy the episode. All right, welcome to the pod, Ted. How are you doing today?
Doing great. How are you, Silas?
I am super excited. It's been a long time coming to get you on the spot. I think we were supposed to do it in the spring originally, but you've been a busy man. So I guess just tell us, everybody, you this past 12 months from an outsider looking in, seems like it's been a really exciting and busy time for you. What are some of the big accomplishments you guys have had in the past 12-ish months?
Yeah, 12 months ago, it was just me at the company, and we built up an entire team. Since then, we're at more than a dozen people right now across the El Segundo head office and then in the field as well. We built a drill rig from December to May, got that out in the field a little bit of summer for some testing some automation that has not really been used in this area yet. So it's been exciting.
Yeah, there's a lot of really cool things you guys have been working on. So I guess what are some of the things for you personally that felt like the biggest milestones or highlights over the last few months that you just like, that was kind of a surreal moment?
Yeah, I think building an engineering team is probably what I'm most proud of. Going from someone who I started the company in college, I worked a few kind of technical internships, and I grew up around the mining industry, but I haven't worked on a project nearly the scale of what we're building now. And so seeing a team come together, the mechanical software and control side, to actually kind of be aligned into my mission in this company to reshore mining to America, and having these people from all different domains, not just from the mining industry, being excited about what we're doing. I think that's what I'm proudest of. Technically, we've done some pretty cool things that I think we'll talk about in a little bit when we have a little bit more context. But I think building the team is, that's what I'm excited about.
It's got to be pretty rewarding to see everybody come together. And I think I just heard recently you guys have convinced quite a number of people to actually relocate out. So, getting people really behind that mission must be interesting. I'm always curious when people have kind of this beginning and launch that goes so quickly like Durin has, like, what does it feel like to be trying to steer this rocket ship that just seems to be taking off very quickly? Is there like any kind of mental games you're like, man, like how do you deal with that?
Yeah, you got to work a lot. And I think we have a pretty clear thesis that drilling is the bottleneck in mineral exploration, and our product roadmap is clear. And so, sticking to that critical path, I think, is most important. Not losing focus. That's what aligns everyone, and then being transparent with the team. That like these are the things we need to accomplish. If we don't accomplish them, the company dies, and it is materially worse for America and our allies.
Yeah, I really appreciate kind of I don't know how I would position this, but like the absolute focus you guys seem to have and understanding what those milestones are. Because from if I was working in the company, it's like it's hard. It's very difficult to build hardware in the first place. But if you can understand what needs to truly be done, then you can get there. And I think this is a good thing that other climate founders should really consider, because a lot of people are building in hardware and they need to get really clear on those objectives, because otherwise it just feels like you're trying to follow some software playbooks, and those are just not going to work. So let's talk about mineral exploration. So I am pretty unfamiliar with this space. We've talked about minerals on the pod before, but never the exploration part. So can you just explain how it works today?
Yeah, so mineral exploration is really the process of finding a mineral deposit, delineating it, figuring out the size and grade, or kind of what percent of whatever mineral or metal you're looking for within the resource, figuring out how big it is, and then figuring out whether it is economic to mine or whether you should abandon the project and find something else. And this is an incremental process. At the earliest stages, you may have a geologist who has a theory that there is some deposit here. You can run geophysics surveys looking for some sort of gravity anomaly where the rock is denser, where the rock is more magnetic or conductive or resistive, et cetera. You can do seismic, figure out, where there's these density boundaries between different types of rock. And that'll really, you're looking for where the rock is weird. Where is it not different than the rock around it? Because any mine, it's an anomaly. It's mining is a power law industry, and mineral deposits are not at all homogeneously distributed. And so it takes a lot of work and a lot of capital to find these larger deposits that are economic to extract the metals from. So you can do geophysics, you're looking for where the rock is weird. You can do soil sampling, where you're kind of digging down a foot or a meter, something like that, collecting a small sample of soil, sending it to a lab to figure out whether you're really looking for trace amounts of various metals that may indicate a much larger amount further down beneath the surface of the earth. But then really the big part of mineral exploration is drilling. And when I say drilling, the most common type of drilling used in mineral exploration is what we would call core drilling or diamond drilling. And this is where you're collecting cylindrical core samples. Most commonly, it's about 2.5 inches in diameter. And you're going to drill these holes anywhere from hundreds of meters to a few thousand meters in depth. And then you'll get all this rock, you'll lay it out on a table. The geologist will traditionally take notes on it. You're looking for, like, what are the minerals they're seeing? What are the interesting structural features? How kind of consolidated is this rock? Where are the fractures? Stuff like that. And then you'll chop it up into various increments, generally about a meter, and then send these samples off to the lab. And then the lab will assay them, tell you the kind of exact composition of this rock. And then you can plug all this data into a 3D geological model so that you can visualize the ore body. And then you can start to get a resource estimate to figure out how large the resource may be. You can see where is the ore body blocked off. We've explored, you have the ore body here, and then over here, there's not really anything. So we need to drill this way. And so going to plan the next drill program to do that. And so mineral exploration, you have this constant cycle of kind of geophysics at the start and then drill. Most of these exploration companies are publicly traded, basically startups, and they'll raise capital incrementally. And so they'll raise more capital to drill and then analyze those results, raise more capital, and drill more. You might have 10 or 15 cycles of that by the time you have enough confidence to build a mine. The thing about mineral exploration is that most of these projects fail. It's somewhere between 1 in 100 and 1 in 1,000 exploration projects end up turning into a mine, depending on what you consider a mineral exploration project. And so most projects die. It's really very analogous to startups, where it is very few end up working out. And so the key is kind of doubling down, having a wide amount of bets at the start. Maybe you're looking at a particular geography, but evaluating a bunch of projects, hundreds of square kilometers sometimes for some of these larger companies, but then really focus your efforts and capital on what is most prospective.
Hey guys, we are super excited to announce that we are partnering with Climate Hack to make content for the upcoming Hack Summit that is returning to New Lab from December 10th through the 11th of 2025. The Hack Summit brings together 500 founders, funders, and industry leaders in the climate deep tech world. Together, we'll be exploring abundance alongside founders and investors from Andreessen Horowitz, Brimstone, DCVC, Durin, Earth AI, Endolith, Navier, Radical AI, Rainmaker, Voyager Ventures, and SOSV, just to name a few. If you're interested in attending, sign up today for 10% off. You can find the link in the description. We look forward to seeing you there at New Lab December 10th and 11th of this year for the Hack Summit. All right, back to the show. Interesting. So I'm trying to break this down a little bit, and you kind of just clarify this for me. So that's the traditional method. Is kind of like, hey, we're going to drill around. We're poking out. We've got a human element, or pretty much all human element, right? We've got people going out there in the field drilling, and probably remote places, I would assume, most of the time.
Middle of nowhere.
Yeah, yeah. And then you have to have the scientists or the geologists kind of check everything. So what is, I guess, you mentioned a couple things. How do they, first of all, develop theories of where they might drill in the first place, traditionally?
Yeah, the best place to find a mine is next to an existing mine, and so there are that's an old adage from the mining industry. Yeah, there's because mining is a power line industry. I keep coming back to this. If you have one mine here, there's probably a lot of that you probably have not discovered the whole deposit, or maybe you found that one deposit, but there's others nearby. And so, like, for example, northeastern Nevada is the biggest gold producing region in America. I forget what percentage, but it is a massive percentage of U.S. gold production. And there's like a dozen mines within 50 miles of each other.
I see. Okay. So that's the theory part. So they just kind of base it off of, like, the rough
And then,
estimates now.
and then
Are there?
historically, it would be a guy walking around and they see somewhere in the ground. And then there have been discoveries made just through pure geophysics. But yeah.
So there's no kind of existing technology to figure out, like, hey, I think we had somebody on the pod a while back that said they believe that it's possible that through, I'm going to get the technical terms wrong, but there's like satellites that use, I think it's high spectroscopy.
So the one that's used kind of most commonly in the mining industry, it's not super common, but it is used today, is hyperspectral imagery from satellites. And so that basically, we can see basically RGB somewhere between 400 and 700 nanometers. It's a little bit around there, but generally that range. And then hyperspectral goes from like 700 to 2500 nanometers. And so instead of like a camera just collecting RGB pixels, hyperspectral cameras can collect like 100 different wavelengths. And then there are some minerals that might just seem white to us when you're looking at it, but then they stick out in a way that is easy to pick up on a hyperspectral
Interesting.
camera. I'm not an expert at that, but that doesn't work when you're in a jungle or something, because then it's like at the surface. So it really works well when it's like a desert and you're looking to actually see the rock.
Completely arid or something. Yeah, okay, that makes sense. So, and traditionally they're doing this, I guess, is there an estimate on how much is typically being spent altogether to find a new mine? Is there an estimate on this?
Yeah, so mineral exploration spend last year in 2024 was $12.8 billion, basically globally, ex-China, ex-Russia, which we don't really have data for. And then basically the average exploration cost, or average spend, basically prior to building a mine in the Western world is $218 million on one deposit. And so that is paying for the drilling, the geophysics, on the feasibility studies you end up doing, the metallurgy studies. And then for that's nearly $250 million spent prior to building a producing mine. It's another $500 million or so spent on projects that end up not becoming mines. And so you're looking at, for every mine that comes online, every major mine in the Western world, $500 million, $750 million spent.
And then the average output, like, do we have numbers on that? Like, what does the mine actually have as a result?
It seems like these are for kind of major mines, which will be producing billions of dollars of raw materials for the life of the mine.
So that's why they're willing to spend so much upfront. Okay, so this is the traditional method.
And actually, another note on that, which I think is just interesting, and something I hear a lot of people talking about within the mining industry, is you value mines on the net present value of future cash flows, which makes sense because you only know what you know. You can estimate. You can only drill so much. And what a lot of people in the mining industry complain about is, if you were to drill basically until you run out of economic ore to drill through prior to building the mine, there's some mines that might never get built. And so the deposit might be miles by miles in width, but it would take 20 years to drill all that out, or 50 years. And so you spend 5-10 years drilling. It's a great mine. You build it, but then the company's market cap and what they can raise capital at is only valued on what they've drilled out, and maybe some premium for all the kind of rest of the deposit that's around that mine. But it's not fully priced in, which a lot of course, mining CEOs complain about. And I think it's a valid reason, but we don't know what we don't know. And so That's why
So,
I
so
stopped
are
with
you
that.
saying that the point could be that if they had an economic way to actually identify the rest of the mine, it could help
Yeah,
the existing operation? Is that your point?
exactly.
Okay, I see. So, okay, so we've covered, I guess, the traditional methods, and I'm not going to even ask about how long it takes to typically do that. But what you guys are doing specifically different? Like, what is Durin doing to solve this problem?
Yeah, so we come in a few different parts of this. The main one is drilling. So drilling, this core drilling, which I discussed earlier, that's the most common type of drilling used in mineral exploration. There are a few other types that are less than 50% of drilling. The most common type is RC drilling, reverse circulation, where you're basically pounding the rock with a downhole hammer that's spinning and you get rock chips. But in core, you get nice, pretty cylinders of rock. So what we do is we are building cheaper, better, faster, and safer diamond drill rigs or core drilling rigs. So how are we doing this and why? Drilling is more than 50% of exploration spend. At the earliest stages, it might be 75% or 80% of the cash that an exploration company is raising is going towards drilling. The later stages, maybe 50%, they're doing a lot more drilling, but they're also doing a lot of kind of metallurgical test work to figure out how you're actually going to process the minerals. Regardless, drilling is around 50%. So for every mine that gets built, you're looking at on the order of $100 million plus being spent drilling out the deposit, at least on a major mine. And that is ridiculously expensive. The operators of these drills, drilling contractors, basically most exploration companies or even mining companies don't own and operate their own rigs. They hire a contractor that buys the rig from the OEMs and then charges a per meter service to these exploration or mining companies. And so that's what we're doing. The problem here is that these contractors, 50% of their spend, 50% of their cost is labor, and that cost is going up. This is being a driller on one of these rigs, you have 3 guys per rig, is a very difficult job. You're out in the middle of nowhere, oftentimes at a 20-day on, 10-day off rotation, not ideal. In the heat, the cold, it's tough work. People get hurt somewhat frequently. Yeah, it's not ideal. And so you have to pay these guys a lot, and there are increasingly fewer of them. And so labor cost is crazy expensive. And so as a result, drilling costs are high. And so what we are trying to do is automate this, really augment the existing drillers that we have, to really kind of alleviate the labor constraint that this market has right now. And so how does automation in here work? You have 3 guys per rig. One of those guys is the driller. He's the guy in charge on the rig. What he is doing is he is on levers, adjusting a few different parameters on the rig. The RPM, so how fast the bit's spinning, the weight on bits, the amount of force applied to the drill bit, the flow rate of the drilling fluid that you're pumping down hole, pressure, as well as torque of the drill string. And then you can manually adjust the viscosity of the drilling mud that you're using. And so he's kind of doing this almost like knowledge work task. It's very difficult and out in the middle of nowhere, but he's doing that. And he's listening to the rig and then looking at a bunch of gauges. And then you have 2 guys called helpers. And these are the guys doing a lot of the manual work on the rig. Some of the big manual tasks are loading rods into the machine. All drilling is threading rods together and then pushing and spinning them into the ground. So loading rods in and then taking rods out is very manual. You have mud mixing, so basically dumping bags of additives into your drilling fluid to adjust its viscosity. Basically, you need to adjust the viscosity of your mud such that it can support the weight of the cuttings. So like you think about like a handhole drill, you get all the cuttings as you're going through wood or metal or something. Same thing in rock. And then rock is different density. And so if you're going through more dense rock, you're going to need more dense mud in order to support that being basically pumped back to the surface,
Okay.
hundreds of thousands of meters, as well as keeping the bit cool. And then you have core extraction. And so this is basically, I'm not going to go into the whole thing about how the drilling system works, but you have your drill rods, and you have another kind of smaller cylinder near the drill bit, which is what your core sample slides into as you're drilling. And in order to retrieve that, you lower a tool called the overshot, which latches into place, lets you pull up that inner tube containing the core, and then you've got to have a human take that out and then reset that system. And so automation is really a few different components here. It is, first of all, making these rigs such that you can control them with a computer, basically making these rigs drive by wire, like modern cars. Today, you literally have guys, the levers they're adjusting are opening and closing valves manually. These gauges that they're looking at, this data is ephemeral. It's not being stored anywhere. And so storing all this data and making it drive by wire is the first step. And then basically using robots to do what all these humans are doing, starting with the rod handling. And so with that, we think we can reduce the labor cost around 75 or 80%, get this to a point where you can have 2 or 3 guys operating a fleet of 5 to 10 rigs instead of needing 3 guys for 1 rig.
I see.
And then as we kind of optimize our software over the next few years, make it such that we are drilling more precisely. And what I mean by precise is better adjusting these drilling parameters that I mentioned earlier. Sometimes you're going from one type of rock into another type of rock. As you're going through that transition, the machine starts making some weird noise. The drillers don't like it. And so they'll up the RPM until the noise goes away. And sure, maybe you're drilling. It's not going to hurt the machine right now, but you might wear down your drill bit too
I see.
quickly. And if you wear down your drill bit too quickly, you're going to need to trip up all of the rods to change the bit and then put all those rods down. And all of a sudden you've lost 4 hours when you could have gone a few more hours before needing to do that. And that adds up. And so having software controlling these drilling parameters gets us an increase in efficiency. We think 50 to 100% increase, as well as I think we can better kind of optimize our mud additives use. And
Really?
so
Wow.
overall, 50 to 75% cost reduction in this drilling step.
So in the entire operation, you think you can reduce it? What you say, like 50%
So yeah,
roughly in total?
I think in the next few years, I think we'll get
Yeah.
down to about 75%. Is I think
Wow.
near the kind of physical limit of how low you can do diamond drilling. And the one other valuable thing that I think we are doing is you have this kind of heavily instrumented rig, which we need all of these drilling parameters for us in order to automate the rig. This is also valuable data that the client wants. These exploration companies want. Today, in order to know what's going on in the drill rig, you just send your geologist out to check the drillers if you want to look at the core, or like call them up and say, how deep are we? What is the rock looking like? And this driller with no geology training is going to tell you what color it is. Some of these guys actually know a lot about rock, but certainly not as good as the company's geologist.
Yeah.
And so what we're doing is you have all this data that we're already collecting, like first of all, web UI that you can log into and kind of really visualize exactly where you are in 3D space on this website, which no one can do today. Kind of a live updating.
I see.
You can see the rig turning on the UI. And then we also have some sensors. We were talking about hyperspectral satellites earlier. We were going to put those basically on a little rig scanning box next to the drill rig, as well as a few other sensing techniques, so that you can basically get a good understanding of what you're drilling through as soon as you've pulled up that core out of the ground. So I'd say it's near real time, a few minutes delay after you were drilling through it. And so that eliminates the need to have a geologist on site checking in with the drillers, because really what these guys are trying to figure out is, when do we cut the hole? Do we keep going? You might cover the target depth of 2,000 feet, but if the rock's looking good, let's keep going. Or if we haven't hit something that we were expecting to hit, let's cut the hole short and save some money and spend it on the next one. And so eliminating the need to have the geologist out on site is key. A lot of them still want to be, but giving them that option and this additional data.
Hiring is a pain. Posting jobs usually means a pile of low-quality applicants to sort through, but going out and finding them yourself also takes a ton of time. So using a headhunter to save you time is often cost prohibitive, but not anymore. EarthSearch works specifically with early-stage clean tech startups to hire the best talent so you can hit your next milestone. We work at prices that even a pre-seed startup can afford. Save yourself time and money on your recruitment by reaching out today. The best part is we offer a hiring guarantee. So if the candidate isn't the right fit, you get your money back. To get in touch, reach out to me on LinkedIn or go to earthsearch.com/contact. That's ERTH search.com/contact. Happy hunting. Yeah, I mean, if you could just have one person managing, one geologist for multiple rigs instead of one per rig, that could be helpful. So just to try to recap this, the core things are you're reducing the number of staff needed out there, and you can have one team that can manage multiple instead of one team managing one. And then on top of that, you're getting better efficiency out of the actual rig itself, because you can make sure it's operating more efficiently, not breaking down as quickly. And then on top of it, there's this value add component, which is the extra data that can be then shipped right back to headquarters, for example. Correct?
Exactly. I think there's four value adds here. Really cheaper, faster, more data, and then safety, less liability for the client.
Yeah, true. Okay. So I'd be very curious, how are partners open to working with you guys? Like, are they pretty interested in the innovation here, or are they really hesitant to try new things?
I think there's some that are skeptical, but by and large, the mining industry knows that this is coming. But mining as a whole does not like to invest in R&D. We're not particularly good at R&D. And that is because commodities are cyclical. And so therefore, mining companies and everything related to the mining industry is cyclical as well. And so we as an industry tend to hoard cash in the event of a downturn and not really reinvest in the future. Really, the only people that I think are doing a great job at R&D are somewhat counterintuitively the mining majors, like a Rio Tinto or BHP, some of the largest mining companies in the world, because they have these massive iron ore businesses cranking out 10 or 20 billion in profit a year. And so, and a 1% improvement to them is $500 million. And so they're going to try to automate everything and kind of, eke out every percentage of efficiency that they can. I was in Australia at the start of May, and I went to Rio Tinto's remote operations center. Rio Tinto is the second largest miner in the world. They're based in Australia and the UK. Iron ore in northern Western Australia is their kind of golden goose. But we went to the remote operations center, which is by the Perth airport, because they need like 100% reliable power. And so they're by the airport. And you have like this massive room, and there's these like circles of tables. It's like 8 guys in there, or 8 people in there. And they're like on the phone. Everyone has like 8 monitors, and like these are the guys that are operating a mine in Western Australia. Like this, less than a dozen people are coordinating and controlling these pieces of equipment that weigh hundreds of tons from thousands of kilometers away. That is Rio Tinto's engineers that have built that. They pushed Komatsu and Caterpillar and other OEMs in order to innovate. Really, innovation happens in mining when someone with a lot of cash, the mining majors, kind of do a partnership with an OEM. The OEMs I don't think are great at innovating internally.
Yeah, I mean, I can imagine that. We've talked about a lot of big numbers here, but if you said they're exploration companies, they probably are even though the numbers look large from the outside, they're probably relatively small in
Well, and
terms of.
that's one of the problems with exploration is that exploration companies are by definition smaller companies.
Yeah, exactly.
Majors, and it's heavily fragmented. There's not really a like massive exploration champion that can push one of the big OEMs. And so as a result, it's not a priority. And it's also a much smaller market than kind of producing mines. And so it's sort of been left by the wayside is my take on this.
Yeah. Okay. So what is I want to get into the part where we talk about the U.S. kind of mining market. So you're working in the mining space or exploration space, and some people wouldn't necessarily consider that a climate technology. I consider it climate technology because of all the stuff behind it. But can you just talk about what's the landscape look like right now from an investment in critical minerals in the U.S.? Is there a lot of interest in this, like kind of getting more national security? Like, what's your general take, and what do you see going on out there?
Yeah, it's not related to critical minerals, but just I think an interesting thought to kick this off. The second highest performing stock in the S&P 500 this year is a mining company. There are big mining companies in the U.S. That's Newmont, by the way, and then first is Palantir, of course. But 2 of the top 10 largest mining companies in the world are American: Freeport-McMoRan, which is copper in Arizona, and Newmont, which is primarily gold in Nevada. But it should be more. The U.S. has sort of given up its mining industry to the rest of the world over the past 100 years. We were a mining giant in the early 1900s up until about the turn of the century. Similar story, I think, to manufacturing, that we kind of chose that we do not want to do these things here. The U.S. is one of the most blessed countries in the world, geologically speaking. And we have Canada next door. And I think it's really the U.S.-Canada relationship in mining is interesting because like most U.S. exploration projects are run by Canadian companies. You have the Toronto Stock Exchange and then the TSXV, the venture exchange in Canada, that are where most exploration companies are listed. They're listed on the TSXV if you're in North America, or the ASX if you're in Australia, and then that's most exploration companies globally. We used to have these penny stock exchanges in the Western US, and then that were mostly mining stocks in the 1900s, but then kind of shut those down. I don't really know exactly why, but I think it's mostly cultural. That we have kind of a few mining giants, but we've decided that we don't want to mine here. It's a bit of a NIMBYism. There have been a lot of kind of bad environmental practices in mining historically, and I think as an industry, we've cleaned a lot of that up, at least in the Western world. I do think that mining should be heavily regulated on the environmental side.
Yeah.
I think the problem that when people in the mining industry complain about permitting, I think the biggest complaint is really about permitting timelines and lack of certainty in that. Like, no one wants to. I haven't met anyone in the mining industry, at least in the U.S. and the rest of the Western world, that is not concerned about the environment. Most of the geologists I met, really every geologist I meet, gets into mining because they love the outdoors and they love the earth. And it's like, I think it's a deep respect that I think everyone who's close to the rock has for Mother Nature.
Yeah.
And like we are sucking at its teat and like using these natural resources that God has endowed us with for the good of humanity. And I think that's kind of the vibe that a lot of the people I surround myself with in the mining industry have. And so, yeah, it's a deep respect for Earth and the climate. You're obviously scarring it, but it's a relatively small percentage of the Earth. And I think of it more as terraforming. And like a
Yeah.
mine, no more surface disruption than a big subdivision. And plenty of us
Mhm.
live in like those houses.
Thankfully, I don't live in a subdivision, man. I would
Yeah.
not like that. But no,
Or a
I
city.
do I do think that this is I do think this is a very interesting perspective. I mean, America doesn't seem they had kind of this nastiness because you said the bad practices, and instead of trying to just improve the practices, they tried to just say, hey, let's get rid of this entirely. So I don't know. We're not going to dive into the history of all that happening, but I do remember growing up there was meant to be a mine. I don't remember what type of mine, but way in northern Wisconsin in Ashland, I think, and it
Okay.
would have revitalized the entire region because it's like a
Yeah.
totally dying city and or town now, and the environmentalists kicked it out, and it never happened. And now the city continues to die. It's very very sad to see because that's where my mom grew up. So I
Well,
do
and
want to
like,
see us build stuff again.
yeah, and Minnesota historically it was the Mesabi Iron Range where we get all
Yeah.
of our iron here, and then now there's nickel up there that's highly prospective, and copper. Glencore is a great project up there, but we can mine nickel in the U.S. or we can mine it in Indonesia, which produces half the world's nickel, where they are dumping acid into the ocean and into rainforest, and it is absolutely awful. And so we have this choice to make where, yeah, maybe there might be a slight downside here. I really don't think so, or there is definitely downside elsewhere.
Yeah. This is the whole point. It's like why would we want to, I think if I'm not mistaken, some of the natural gas or fracking industry was really like, hey, we're going to stop doing this in the US and we're just going to have other countries do it, which they don't do it nearly as cleanly. So,
Yeah.
we have to make that recognition that we do have a much more robust regulation kind of setup here, which is, in one way positive, but we need to work together to actually still build things. And I think this is the back and forth stress that we see. I'm hoping, these things change, but I guess from your perspective, do you see any? A lot of people are very negative on the Trump administration for the climate industry, but do you see any like big positives that are coming out of the current kind of uh, goal to have onshore production of these things? Like, do you see any kind of silver linings there?
Yeah, absolutely. I'm very excited about what this admin is doing. Mostly on the permitting side, they are pushing projects through that historically have been blocked. I think a great example of this is the Resolution copper mine in Arizona, which had some issues with native land. There's a lot of debate over whether it should get built, but by and large, I think it should. And Trump pushed it through in his first administration. It was one of the first things Biden did was cancel this massive copper mine that would have been the largest copper mine in the U.S. And so we
Mm.
talk about needing electric vehicles and batteries and all of that, but we actually need to put our money in kind of legislative acts where our mouth is and build those here. Otherwise, we're going to be importing from South America or Africa or eventually China. And so that's, I think, the best thing the Trump admin has done is kind of accelerating permitting for select projects. I think we need to see a bit more kind of broad, I don't know what you'd call it, but like, might even need legislation to kind of finalize, get in law accelerated permitting timelines or
Yeah.
setting permitting timelines, reforming NEPA so that it doesn't go on for 20 years for some projects. But because right now it's kind of piecemeal project by project by executive order, which is not a great way to do things. I think it's a
Mhm.
fine stopgap to do as we are in kind of a sort of emergency right now. But I do think we need broader change here. I did my first proper trip to DC a few weeks ago and met with a whole bunch of people in a few different parts of the federal government, and everyone is so excited to help startups. And our conversation was pretty much all about mining, but everyone that I've talked to is really excited about what we're working on and really about the mining industry in general and want to help in any way that they can. And so yeah, I think it's a program that's been saying when you hear drill baby drill, you should be thinking mine baby mine. And I think we need both. And I think particularly those that want to move to a net zero economy, I think we need to trade a lot of our drilling for mining. And I think that's
Yeah,
a
because
really
we can't. I mean, on the point of the copper, right? If I remember correctly, when Liz came on the episode on the pod, Liz Dennett a while back, she was saying that the kind of the biggest bottleneck to actually electrify everything is copper, right? And we
yes,
do not have nearly enough copper in the world, much
yeah,
less in the U.S., right? So we need those copper mines, and it doesn't, it doesn't exactly square with what the Biden administration's objective was for electrification. So I think we've got these, there's very difficult
and
time.
I
I
think
think.
it's I think just an interesting note. I think comparing the two admins, I think there's a similarity here, which is I think is somewhat interesting. In one of Trump's early executive orders, I forget which one, he basically, for permitting for accelerating permitting of certain projects, he basically waived some kind of, I think it's what is it, SK 1400, something like that, kind of disclosure requirements about kind of mining, about kind of the basically being transparent about drill results on mining projects and kind of putting together comprehensive data, which is needed in order to say that you have this resource and this reserve in the deposit. You need a whole bunch of data as mandated by law. We have it in the US, Canadians have it, the Australians have it. It kind of waived this requirement, which I don't think is a good idea. I think we can strengthen those requirements because there's a whole bunch of mining projects globally that get funded by people who are, I don't want to say snake oil salesmen, but are kind of fudging the numbers on some of their projects, or at least spinning the story heavily. They're mostly selling to retail investors who will often eat that up, and there has been fraud in the industry in the past. And so I think we have an opportunity. If I were in charge of the kind of mining policy in the government, I think we should be giving out ridiculous sums of money to make sure we get these mines built quickly in the U.S., but have the strictest disclosure requirements in the world, so we make sure we are funding projects that are legitimate and are actually going to help our economy. And I think it's a concern I had with the Biden admin through the IRA and other acts that they're funding battery companies or process technology companies that are not vaporware or somewhere on that spectrum. Companies that are spending billions of dollars on projects that are never going to get built or never going to work. And that's my concern with mining as well, is I see mining companies engaging with the federal government that are low-grade assets that are not going to be economic to extract from.
Mhm.
So we need more diligence
Yeah.
there.
Yeah, on a that's a really good point. On a high level, do you I mean, is there any estimate as to like the things that we know we have in the US in terms of mineral deposits that can help with just national security from also from a electrification perspective, but also from a national security defense perspective? Like, do we
Yeah.
have any idea of what exactly is here and how much of that supply chain we could solve ourselves if we had mines in all of those places that are known today?
Yeah, we'll talk about copper first. Most of the copper, I think it's around 80% in the U.S., is mined in Arizona, and that's where Durin is focused on operating right now. There's a lot more there to mine. I think we should run really tight spacing geophysics over a lot of the state, figure out where those anomalies are, and then incentivize explorers to explore and drill there. I don't think we'd be able to be self-sufficient in the next kind of 10 years. And I think we should be increasing demand still along with our standard of living. And so I'm not 100% sure we could be fully self-sustaining, but we could be close to it. And then with recycling, probably be good. So copper,
We should talk about
we're
that.
fine on. There's rare earths is what a lot of people talk about. Before starting Durin, I worked for a company called MP Materials, which operates the only rare earths mine in the U.S. in California, a little bit west of Vegas. And right now they're around 15-ish% of global production. They did a really interesting deal with the federal government where the DoD invested in them, owns 15% of the company, and set a price floor. I think it was $115 a kilogram for NdPr, which is a basically first kind of quasi-state-owned enterprise since World War II. And so unprecedented there. But yeah, there's really not many other exciting rare earths deposits in the U.S. Mountain Pass, this mine in California, is world class, and there's only a few mines like it globally. There's one in Australia, and then China has one mine that produces between 30 and 40% of global supply. But there's some projects that could work, and there's a lot of research going into extracting rare earths from tailings, which could be interesting. Or there's a project in Wyoming with Ramaco Resources looking at extracting rare earth from a coal mine, where you basically it's a rare earth mine, but then your tailings is basically coal, which also has value, and so that could be a solution there. But then there's really exciting rare earth deposits in Brazil. And I think South America is going to be really, really key for us. We need a new Monroe Doctrine for critical minerals, is my opinion on this. So much Chinese investment going into South and Latin America. That should be us. And I mean, a lot of the big copper mines are owned by Australian companies as well, and Canadian companies. And then Codelco, the Chilean state copper miner, is the biggest copper producer in the world. But yeah, we need more involvement
So
there.
maybe just to put a fine point on this for people to understand, like we need to do these things from number one, if we're doing it, it's going to be much cleaner, first of all. And if we do it with our partners and in conjunction with you, even if it's in Latin America, it'll be cleaner. But on top of that, if we don't do this, right now, I mean, maybe you probably have the stats on this, but right now, most of this mining and refining is being done mostly by China, if I'm not mistaken.
Yes, yeah,
And
China
look,
dominates refining.
Yeah, and we're completely dependent on them, which is really not good for national security. And again, regardless of how people feel, I think that it would be very irresponsible for any country to be completely dependent on some other country, regardless of who it is. I think that anybody can agree on this if we set aside our political differences and just focus on like, hey, we need to take care of our country, right? So there's a lot of things we could go on. I wanted to get your quick take on all the items that are important to mention around recycling. I don't know how to ask the question,
Yeah.
but you mentioned recycling, and if I understand correctly, metal can be recycled in a really interesting way. So can you talk about that part?
Yeah, I'm not at all an expert in recycling. I'm interested in recycling the same way I'm interested in mining. I think pulling rock out of the ground and getting metal from it is magic and really, really cool. But if we're sourcing metal, like landfills are basically ore. Yeah, ore is just anything that contains metal that can be economically extracted. And so anything can be ore if it's economic to extract it. It's a matter of finding either kind of collecting or really finding the technologies that can extract metals from kind of highly mixed substances. Like circuit boards or something like that, or batteries. And it's very difficult because a lot of these chemicals are tough to separate, require a lot of energy to do so. So it's something I'm interested in. It's not something I know a ton about. Like copper is easy to recycle. But yeah, if it's in a
But
battery,
but
really.
is the point that if we are buying all these minerals or these metals from other people, once they get into our country, we should be able
We
to
sh-
maintain
yeah,
them, correct?
we
Or
should we should build a circular supply chain.
okay.
Absolutely.
Yeah, okay, got it. All right, so there's a couple of things. We're gonna run out of time to cover everything, but I want to ask you about the fundraising aspect. So you guys have raised both from climate funds and just traditional VC funds, right? You can mention the ones if you want, but how do you, as a founder, I guess, on the branding side of things, go about kind of pitching this? Do you even talk about climate at all? Or you just, hey, we're solving a problem. You just focus on that only, regardless of who, what VC you're talking to.
Yeah, I think what motivates me is like the moral imperative that I started the company around is the national security one, that America is not secure unless we have a good control of our supply chain. We won't need to bend the knee to someone that controls a large percentage of our supply chain necessary for our modern way of life. So that's what motivates me. We have people at the company that are interested in mining because of the climate implications of it, and I think that's great. I think they're true, and I think that's not as important to me, but I think it certainly is still important. I love my Tesla. I think it's better than any gas car that I've driven, certainly. And I want the technology to be available for all and not have to. Really, the kind of like Elon style mission statement that I say for Durin is I want to ensure that raw materials are not a constraint on humanity, and like that is really what motivates me. I want the copper to flow like water or something like that. Not really, but at least like not be a bottleneck.
Mm-hmm.
So yeah, I think we are. You could certainly call us a climate company. I think we are helping the climate cause. I think we are just as equally helping the defense cause. Really, raw materials are something that is kind of uncontroversial, or at least I think should be uncontroversial, unless you are kind of anti-humanity and want us all to go back to living in caves. We need a vast supply of raw materials. We got to get them from somewhere.
So is that the same pitch then? Like when you guys are pitching to VCs that
Yeah,
are kind
yeah.
of climate focused?
There's a few different ways to do the pitch. I think I'll generally talk about both, and
Mhm.
I'm not going to like talk about climate for half an hour if I'm going to call with
Yeah.
a climate
But
VC.
the goal
But
would be probably, I'm assuming, you correct me if I'm wrong, but it's first like, hey, what's the business model, what we have here?
yeah,
And then if you are pitching to a climate related VC, then you can kind of bring in, hey,
talking about
here's
the
the
climate
climate benefit.
implications. Yeah,
I see. Okay. Yeah,
yeah.
because
I think
again,
we can fit into a bunch of different funds mandates.
yeah, that's exactly the point. So I really wanted to ask you this because I think a lot of founders struggle with kind of bifurcating how they go about this because there needs to be like you can't completely change your pitch deck depending on who you're talking
Yeah,
to, right? You need to have like the same kind of core message, and then you may kind of insert a couple things that are more relevant to what they care about, and it's just
yeah.
like any sales pitch, right? So
And
I
it's
think
like
that.
it's. I think we have it on our website. We definitely have it in our deck. Like there's a few at the start of our pitch talk about the kind of supply chain shortages or kind of what does the U.S. not produce. And there's like three things we talk about. One is metal is critical for defense. Two is energy transition, not having enough. And then three is AI. AI data centers are going to massively increase raw material demand.
Yeah, so you can kind of play in the intersection of these three things. Yeah, I guess there's a lot of things we probably could go over, but I just want people to really internalize, who are listening, other founders, to recognize what the strategy here is effectively identify what's going on in the broader market trends and how can I position myself in that to solve these problems while also making, a cleaner world in the future. Because I know a lot of people are here motivated primarily by the climate benefits, but you have to remember that there has to be a financial outcome for it, and it has to be some other benefits that you can kind of latch onto, because you guys are doing a great job of this, where it's like you're kind of at the intersection of all of those things, and as a result, you've got friends in many places, as you grow, right? Um, what are you most excited for in the coming, I guess, 6 to 12 months for you guys?
Yeah, I think continuing to grow the team, and we're working on our second iteration of our rig right now. We're excited to get back out in the field, work with some actual customers next year, and so yeah, drilling more holes.
Yeah, nice. Very, it sounds very simple, but I can imagine it's not. It's
A
very,
lot
very
that goes into it.
to build this. Yeah. I am curious. We didn't talk about this too much, but how do you, when you approach these partners, do they typically, we asked before, like some of the bigger ones have the money for R&D, but what are the core things that they want to see out of you to say, hey,
Yeah,
we're willing to actually, do a pilot with you? Because I'm assuming all the drilling you're doing is in partnership with somebody else who's
yeah.
got
So
an
with
operation.
drilling for a client, if there's really, I'll go back to next what I should have talked about earlier. There's really two types of exploration. There is what we've mostly been focused on today is greenfield exploration, which is
Hmm.
you're out in the middle of nowhere, completely new project. And there's also brownfield exploration, which is what we would call resource development drilling. And this is drilling next to existing mine sites to expand the mine. Greenfield exploration, that's really what I grew up around, what my family does. Not great for drillers, particularly for autonomous drillers, because we are still going to need people in the field to do maintenance or deliver supplies and stuff. And so if we need one person in the middle of nowhere, we need two people in the middle of nowhere. Going from three to two isn't great. What we want to do is have 5 rigs on site and have those same 3 guys operating 5 rigs.
Hmm.
And so we need to go where there is a lot more drilling, and that is next to mine sites or at much later stage exploration projects. Also, infrastructure is really important. We drilled over the summer, and it was like an hour and 15-minute drive from the closest town to the drilling site, which was 2.5 hours from the closest airport. Awful logistics for testing hardware, and it's like 12-hour drive from LA. So yeah, next to existing mines, which are generally near towns, is much better for us. And so that's our focus. And at these existing mines, there's what's quite nice about the mining industry is that these larger companies are kind of distributed in their decision making depending on the mine. And so you have the mine manager that's in charge of all mining operations there, and the mine geologist or chief geologist at the mine that is in charge of exploration, and they're the decision maker on drilling. And so it's pretty easy to identify who you're selling to. And then it's a process of doing a pilot, getting on their approved contractor list, and then being able to bid on jobs. And so starting that process next year is what we're excited for.
Hmm. Are there any key bottlenecks that you notice that are adjacent to what you guys are doing that you would encourage any other founders who are looking at building in this space?
Yeah, one of the interesting ones is metallurgical test work, figuring out how you're going to process the rock that you're pulling out of the ground into metal and developing that flow sheet. That is a process that will often take kind of 4 to 5 years at least, and then you'll still struggle with ramp up when you're actually building the processing plant. And so that, yeah, I think that's the biggest one. Geophysics isn't a large enough market to start a company in. I think we've got drilling. I think there's some interesting stuff to do around software, but I think the drilling company that's actually getting the geological data is the one best suited to build that software. So yeah, the metallurgical test work, that's what I'm really interested to see.
Hmm. Yeah, and then maybe one other thing on talent. So you talked about building a team, and it's something you're really proud of. I guess, what are your core lessons on how to attract talent and to get them to join this? Because I can imagine that there's not necessarily that many people who are already in this space, and you also need to find people who have the right technical acumen. So how do you do this? Any core lessons that you've learned over the past 12 months?
Yeah, I think there's three things to screen for. One is, of course, kind of technical ability, and that's kind of, I think, the easiest to measure. Two is intensity, who's going to work hard, and then three is humility. You need people who are going to work well with the rest of your team, and so it's those three things multiply. And
Yeah.
so, I mean, what we've done is we've got references from people, but a lot of what we've done is just cold outreach on LinkedIn, and
Mhm.
works. We put together a great team that way.
And do you find that you know, I mean, you don't have to share this if you don't feel like it, but just do you find that a lot of people are quite motivated by the way you present the mission, that they don't necessarily require the highest pay in the market, or do you still have to kind of make sure you're getting close to what those major companies are
Yeah,
paying?
I want to make sure everyone is taken care of, and we want to be competitive. I don't think yeah, I don't. We could probably push people lower, but I don't. I think
Yeah,
the
you just try to
way
get them paid well.
mining tech is hot right now, you can raise the money, pay people well. Not certainly not above market, and people are getting competitive equity in the company as
Mhm.
well. But I don't want people penny pinching in their personal lives as
Yeah,
well.
yeah.
Um, and yeah, I think everyone is certainly motivated by the mission. I think they're also motivated by the technology that we're building. Drills are super cool, big pieces of heavy equipment, and we're doing some of the actually building software for these. One of the first in the world to do so. So,
Yeah.
like
No, I
that.
mean it's very fascinating. I am sometimes jealous when I see what you guys are doing. I'm like, man, like there's just so many cool hardware companies out there. I'd love to be out there doing something physical, but I'm just sitting here behind a desk. But you know, maybe one day. But I guess last couple things here. Who is another climate founder or just founder in general that you think is underrated and why?
Ooh. I'll give a shout out to Elliot at Watoga. This is another mining technology company. I think they support climate in a similar way to what we do. They basically optimize blast design at existing mines. So basically, when you're in an open pit or underground mine, the way you mine is you drill a bunch of holes in the ground, pack it with explosives, and blow up the rock. And it's normally a grid. But if you have a lot of data about kind of how the rock is fractured, you can do kind of a dynamic drill planning thing where it sort of
Mm,
looks seemingly random, but it's actually designed to blast more efficiently. So you can save a lot of energy on your drilling and money on your drilling and on your explosives and get kind of more finely ground rock, which saves a lot of energy on the
mm.
comminution stage, the rock crushing stage as well. So they're an up and coming mining founder. He also did the Discipulus Ventures cohort last year. I was at the first cohort in 24. So they're great. Unfortunately, they're in Montreal, but I hope to see them again in El Segundo.
Get them moving down to California, man. And then because I'm very fascinated by kind of your entire modus operandi, basically, I'm curious what are the biggest books that have influenced your life in general?
Yeah. Okay. My favorite book is Seven Eves by Neil Stevenson. This one, it's just exceptional. It's basically there's some MacGuffin event at the start, and the moon breaks apart. It's going to crash into the Earth in 2 years. It's hard sci-fi. Takes place in present day. In the first 10 pages, he sets up a scenario where how are we going to get as many people off the surface of the Earth into space to save the species as we can. And I think I don't know if that's what lessons I took out of this. It was more just like a thinking broadly about humanity, but then also Neil Stevenson does an incredible job telling people's individual stories. And I think that's the
Mhm.
way that you want to live your life. It's kind of have this high level view of everything, but then get to know the important people around you extremely well, because those are the people that you're going to save the world with.
Yeah, I feel like I have to start reading fiction. All the best founders seem to read fiction. I've never enjoyed fiction. Well, once I was done with high school, it's like I'm done with fiction. I
Yeah.
just read, you know, like practical books. But anyways, man, we're out of time today. But this has been an absolute pleasure to have you on. I hope we'll bump into each other a little bit during Climate Week. But this has been a pleasure. Any final call outs or calls to action for the audience?
Now, we're hiring. Controls engineers is our biggest priority right now. People to program PLCs, but also software, mechanical, robotics, mechatronics, jobs.durin.com. And if you are passionate about a mission, go start a company and find other people who can help you do so.
Amazing. Thanks everybody for tuning in today. If you enjoyed the episode, please give us a share on social media and drop us 5 stars on your favorite podcasting platform. And if you're feeling extra generous, subscribe on YouTube. It'll really help us to grow the reach there as well as we invest into our short form content. We also love feedback. So drop any comments that you have on future guest suggestions, things that you want to hear more about, things that you really didn't like. Just send Somail or myself directly, a DM on LinkedIn directly. We love to hear from you guys. Thank you guys so much for tuning in and see you next time.